Welcome to a fascinating journey into the quantum world. In today's video, we are going to explore Magnons. Okay, what exactly are Magnons and how these particles, these Magnons, are being used to revolutionize the cutting edge technologies. Okay, I have mentioned these as particles, but actually Magnons are not particles. They are quasiparticles. Magnons are not particles. Means Magnons are not physical particles like electrons or protons or neutrons. Rather, they are quasiparticles. Means they exhibit particle-like nature, but they are actually not particles. Means equations used for particles are equally applicable to these quasiparticles. Okay, that's why these are called quasiparticles. Okay, anyway, so this thing means Magnons, there are so many quasiparticles. If you study solid state physics or quantum physics, then you would see that there are so many types of quasiparticles. Such as phonons are there, excitons are there, then plasmons are there. Okay, but in this video we are talking about only Magnons. So Magnons, these quasiparticles are found only in case of magnetic materials. You know the property magnetism. If you think this property magnetism at the quantum level, then you would see that the magnetism, this property arises due to the spin of electrons. Okay, due to the spin of electrons. And when the magnetic material or the magnet is not disturbed by any external source means such as thermal excitations means may be there. Means if the magnetic system or the magnetic material is being heated up, in that case that is a kind of thermal excitation. If there is no interaction with light, you know, light means photon particles. Okay, so if there is no interaction with photon particles, means if there is interaction with photon particles, then that is also a kind of disturbance. Even if the magnetic material is kept in another magnetic field, then in that case also that is a kind of disturbance into the system. So when the magnetic material, okay, is not being disturbed by any other external sources, in that case the spin or the magnetic moments of the particles remain perfectly aligned. But whenever there is an excitement, okay, when the magnetic material or the magnetic system is disturbed by any external source, in that case there is a change in the alignment of the spin, and that change is propagated inside the material like a wave. That means a ripple of waves are generated inside the material whenever there is an excitement. Okay, ripple of waves. These ripple of waves are called spin waves. And the behavior of these spin waves are like what? Means these spin waves, they are actually quantized. Their energy levels of the spin waves, their momentum, they are quantized. And each quantum of these spin waves are called Magnons. Means each quantum is called a Magnon, since they are quantized. Energy packets are found. Discrete energy levels are found. That's why each quantum or each discrete energy level, those are called Magnons. So behavior of those things are like particles. That's why these are called quasiparticles. Anyway, so this was Magnons, and researchers at present are trying to use this property or use this quasi-particle to create future technologies. And in near future, you can see the use of this quasi-particle in the field of spintronics. In case of these things, the devices we use in our daily life, such as smartphones, laptops, desktop PCs, and so many devices are there being used by so many people, are all electronic in nature, means those are electronic devices. And in electronic devices, the charge of electrons, this property is used. Charge of electrons means current carried through or passing through semiconductors. This type of concepts are used. Means charge is involved, electrical charge of the electrons. Those things are involved in case of electronics. But in case of spintronics, spin of the particles are used. Spin of the particles are used, means magnetic moments of the particles are used. So instead of charge, spin is present here in this technology. But why researchers are trying to use this new concept? Because this is faster, this is more efficient, and this is less energy hungry. Means much energy. If you compare with electronic devices, then devices made using this technology, if you compare the energy consumption between these two technologies, then you will find that energy consumption is much less as compared to the electronic devices. So there are so many reasons. It is faster, such as in case of memory storage. Okay, terahertz speeds, means processing speeds may be of the order of terahertz. Using that much energy, that much speed, we can use memory storage. Means data processing can be done using such high speed of the order of terahertz. Okay, so speed is much higher if you use this technology. Though at present this is not being used, this technology is not being used. But at research labs, researchers are trying to develop this technology. Okay. Anyway, so this was all about Magnons, and in the field of quantum computing, so to transfer data for longer distances with a faster rate, this technology will be used. Means researchers are expecting such things. In case of quantum computing also, this technology will be used. Other fields are also there where this can be used. Okay, this technology. So we can easily say, because means whatever I am saying right now here in this video, this is according to the scientists. In near future, we can use this technology to make our systems, means make the devices faster, more efficient, and less energy hungry, or less energy consumption will be there in those cases. So what is the actually science here? Science involved here? Science involved here is instead of charge, where in electronic devices charge of the electrons are used, and here in case of Magnonic devices or Magnon-based technologies, instead of charge, spin of the electrons are being used. Spin of the electrons means magnetic moments of the electrons are being used. Okay, and reason for use is this is means if you use this technology for data transfer, then in this case data transfer rate is much higher, or the processing rate is much higher if you compare the same with the electronic devices. Okay. Anyway, so this was all about today's topic. Topic was what actually? Magnons. What exactly are magnons, and why these magnons are being used in future technologies, to develop future technologies. Other uses are also there, to study physics in detail, to know the quantum world or to know quantum physics in detail. Because there are still so many challenges, there are still so many unknowns. Means still mysteries are, so many mysteries are involved in the subject of quantum physics. So for better understanding of that subject, quantum physics, better understanding of solid state physics, study of magnons are important. Okay. In other videos, means in separate videos, I talk about phonons are there, then excitons are there, flash bonds are there, so many quasi-particles are there. So what is the summary of this video? If I want to summarize, magnons are quasi-particles, means they are not physical particles like electrons and protons, and they are right now they are being used at only labs. Means experiment is going on by experiments are being conducted by researchers to develop new technologies. And why they are trying to use this technology to develop new technologies? Reason is everything is better as compared to electronic devices, such as this new technology will be faster, more efficient, and less energy hungry. So these are the reasons. Okay. Anyway, so this was all about today's video. This is the end of this video. Thank you. Thank you for watching this video.